Caitlin here, and I'd like to tell you about quantum tunneling. To start off, let's talk about nuclear decay. Decay occurs when a nucleus ejects one or more particles to form a new nucleus. For example, uranium-235 undergoes alpha decay. Alpha decay is a process by which a parent nucleus such as uranium-235 ejects a helium nucleus, leaving behind a daughter nucleus. This decay process with a small amount of atoms is very unpredictable because we don't understand the mechanism of which these atoms actually decay. Mathematically, there is a probability that a certain isotope will decay over time. However, we are still forced to watch and wait for the decay to occur. With a large volume of atoms, the uncertainty of individual decay is blended into an overall decay rate of mass nuclei, where after a special amount of time, called the half-life, half of the volume of atoms would have decayed. According to classical theory, nucleons, which are protons and neutrons, inside the nucleus have a strong attraction force with each other, keeping them inside the nucleus. It's kind of like a spring. If you try to pull a nucleon away, the group responds with an increasing force to pull the nucleon back. This creates a sense of there being a boundary around the nucleus. Another way we can experience this invisible nuclear boundary is when atoms collide with each other. This boundary creates a separation between the colliding atoms, preventing them from fusing together, unless they are traveling fast enough. So the question is, how does a nucleus decay? 1 minute a nucleon can be on the inside of their impenetrable boundary, and the next, it has appeared on the other side of the boundary and is ejected out of the nucleus as a high-speed particle. This occurrence of the particle crossing the impenetrable boundary is quantum tunneling. Particles go where they're not supposed to go. This is where quantum mechanics comes in handy. Quantum mechanics deals with our lack of understanding by assigning a level of uncertainty to the location of particles. So we will know the location of a proton, neutron, or electron with a certain window of error. Science debates whether this is a fundamental particle behavior or a mathematical cover for the lack of understanding of particle mechanics. What are other decay products that exhibit quantum tunneling? Helium nuclei, protons, neutrons, electrons, positrons. It's all so exciting!